we have these two derivative formulas for sine and cosine, and we're going to use these to derive the formulas for the other four trig functions. And so let's start with tangent. So I want to take the derivative of tangent, and I don't want to go back to the limit as h goes to 0 formula. I mean, I certainly could try that because there is a sum of angles formula for tangent, and maybe that would lead to something. I would rather just use what I've got, and so I'm going to use the fact that I know that tangent, there's an identity that says tangent is sine over cosine. And I already know how to take derivatives of sines and cosines, and this is a quotient. So I'll use a quotient rule. That's going to give me the derivative of the top, which is sine, times the bottom, minus the derivative of the bottom, times the top. And then that's divided by the bottom squared. Just cosine squared. And so I'll go through and apply each of the derivative formulas. So the derivative of sine we know is cosine. And we have a cosine there from the quotient rule. Minus the derivative of cosine, which is minus sine. And then that's times the sine that's there from the quotient rule. And that's all divided by cosine squared. So the derivatives are all done. So now I just use trig and whatever to try to get this in a form that looks a little nicer. Well, the top is going to be cosine squared, and then there's a double negative here, so this is going to be plus sine squared, and that's divided by cosine squared. And if we remember any identity from trig, we remember that cosine squared plus sine squared always gives me 1. So that's certainly a lot simpler looking, and typically the way you see this written is we use the identity that 1 over cosine is secant, so therefore 1 over cosine squared is secant squared. And so that's our derivative formula for tangent, is that the derivative of tangent is secant squared. Well, you can imagine that cotangent's not a whole lot different. We just, at this point, cotangent, the identity is it's cosine over sine, not sine over cosine. And then you use your quotient rule. What happens this time is, because there's a derivative of cosine in there, you're going to end up with a negative out in front of the whole thing, because there'll be a negative here when you take derivative of cosine, and then there's not going to be a negative here, so you're going to have to factor a negative out. And so what happens in that case is you get the derivative of cotangent ends up being minus, and it's cosecant squared this time because you're going to have a sine squared in the denominator. So without going through the whole set of details, you can see we're going to get something very similar. Got sort of the same format. The cotangent gives you a cosecant, the tangent gives you a secant, and it's squared. So like I said, I won't work through the details of that one, but let's go to the other two. Let's take the derivative of secant. And again, I don't want to go all the way back to the definition in terms of a limit. So what I'm going to do is use an identity, the fact that secant, as we used in the previous, secant is 1 over cosine. And that allows me then to use the quotient rule. I'm going to take the derivative of the top times the bottom minus the derivative of the bottom times the top. And that's all divided by the bottom squared. So taking those two derivatives, derivative of 1 is 0, so this whole term is going to go away, minus derivative of cosine is a minus sine times the 1. You don't have to write that, but there it is. And that's divided by cosine squared. So now the derivatives are done, and it's a matter of trying to simplify this. Well, this first term's 0. I got a double negative here, so I end up with sine over cosine squared, which is one way to look at it. But what I'm going to do is I'm going to open this up as 1 over, let's put the sine in a second. So I'm going to write this as 1 over cosine times sine over cosine. Still sine over cosine squared, written that way. But 1 over cosine is secant, and sine over cosine is tangent. And that's the formula that you get for secant. The derivative of secant usually is written as secant tangent. So that's how you get the tangent lines. If you want to find the tangent lines to secant, you use secant tangent. In a very similar way, I would write, if I were taking derivative cosecant, I won't write it all the way out, but a cosecant, what I get is cosecant is 1 over sine, and then if you go through your quotient rule back up here, so I'm still going to get a 0 here, but I got 1 over sine. What's going to happen is my derivative of sine is going to be here, and so we won't get this double negative because that derivative of sine is cosine, so there's going to be a minus sign out in front. So the derivative cotangent is going to end up being minus, and what you get when you work all the details out using very similar identities, you get minus cosecant cotangent. Again, very similar form. Derivative of the secant is secant tangent, derivative of the cosecant is cosecant cotangent, except there is a minus. And so that's your other two derivatives of trig functions. So one thing you should notice, you got to memorize them. I mean, you don't want to derive them every time, but the one thing that helps you remember something about these is that minus sign comes about for derivative of every cofunction. Derivative of cosecant is minus cosecant cotangent. The derivative of cotangent is minus cosecant squared. Derivative of cosine is minus sine. The other ones aren't. Derivative of sine is positive, derivative of tangent is positive, and so on. And they have similar forms. When you have a tangent here and a cotangent here, you get a secant and a cosecant. You still, that doesn't help you remember what's over here, but at least you know there's not a cosecant over here. There's no cofunctions in these derivative, in the derivative of tangent. Down here, there's no cofunctions. And this one only has cofunctions. Now, sine and cosine are derivatives of each other, sort of, with one of them being negative. Anyway, so these are just another set of functions that we can use at any point in our derivative when we're taking derivatives. And so what I'll do next is I'll work out several examples where they show up in quotient rules and product rules, and show you how we handle those.